Hello there, Mr. Wilson here again for what is another lesson in this series of bridging the gap between GCSE maths and A-level maths. Now, we've had videos on surds, we've had videos on powers, indices, and the last one was on gradient. So this one is on linear graphs, and there are kind of two different sort of skills here that we sort of need to look at. There is plotting linear graphs, which is one skill in itself, and then there is understanding the equations of linear graphs, and we're going to have a look at that as well. So there's kind of two key skills that are linked in this title, but I'm going to cover both of them. Just before we get into it, if you haven't already, definitely check out all the other videos on the channel, obviously after this one, and subscribe if you haven't done so already, because we are nearly at 3,000, which is crazy to think about. I would have never have thought it would have sort of got there, but yeah, absolutely crazy. Anyway, let's give this topic a go. So first of all, let's talk about the equations of linear graphs, and then we'll talk through some questions with that. So at GCSE, and that's the little asterisk in this, at GCSE, you will have been told that every linear graph is in the form y equals mx plus c. So to give some examples of what an equation might look like, it might look like y equals 2x plus 4 and y equals a half x minus 3. Now, you can get linear graphs that are not in this form, y equals mx plus c, and we'll talk about that in a little moment, but the reason why we would put it into this form, y equals mx plus c, is because the m, the coefficient of the x, the number in front of the x, represents the gradient, and we spent a lot of time working on the gradient in the last video, and this part would represent the y-intercept. Now, intercept means to cross over, so the y-intercept is the value that would the line would cross over that value on the y-axis. So in my first example here, the gradient of this line is 2 because it's 2x, and the y-intercept is positive 4. And in this one, the gradient would be a half, and the y-intercept would be negative 3. A very, very common mistake is for students to get them the wrong way around. That's just misremembering, but you've remembered the right ideas but in the wrong order, so that's tends to be a common mistake. Now, like I've already said, there are some times when it's not in this formation. We'll look at some of those in a second, but before we do that, I just want to quickly mention a couple of other facts about the equation of a line like this. Now, if you have two lines, let's say we have y equals 4x minus 3 and y equals 4x plus 2. If two lines have the same gradient, and that is, if they're in the form y equals mx plus c, that is quite easy to spot because you just got to look at the number in front of the x, the coefficient of x. If they have the same gradient, then they must be parallel to each other. And that means that the two lines run without touching each other. So in this case, both lines have a gradient of 4, so both these lines are parallel. So that's a key fact. Another key fact is the idea that if you have the equation y equals 4x minus 3, again, let's say, and y equals minus a quarter x plus 2. Now, on initial glance, these two look similar, but not as similar as those, but the gradient of this line is 4, right, and the gradient of this line is minus a quarter. Now, 4 and negative a quarter are what we call the negative reciprocal of each other, right? Negative reciprocal. So basically what I've done here is I've changed, and I'm going to use the naughty word here, I've flipped the fraction and I've changed it from positive to a negative, or vice versa. So for example, if the gradient was 2, the negative reciprocal would be minus a half. If the gradient was 7, minus 7 let's say, the negative reciprocal, it changed from a negative to a positive, and it go to positive 1/7. If the gradient was 2/3, it would change to negative 3/2. So that's the negative reciprocal. If two gradients are the negative reciprocals of each other, so two lines have negative reciprocal gradients, then these two lines must be perpendicular. That means that they meet at a right angle. Yeah, so the lines would look something like this. Obviously, that's not a highly accurate sketch, but you're sort of getting the idea here that they must be meeting at right angles. So two key facts there. Same gradient, they must be parallel. Perpendicular gradients are negative reciprocals of each other. Now, it would be really nice if we live in a world where all lines are given in the form y equals mx plus c, but especially at A level, that never usually happens. And actually, and I'm going to add a little caveat to that, at A level there is a second way of representing the equation of a line other than y equals mx plus c. Now, some students might be familiar in further maths because it's mentioned, GCSE further maths because it's mentioned there, but for the most part, at A level you don't usually use this. That has been the rare occasion where I have used this in some of my paper explanations, and you can go and have a look at those on the channel. But we don't tend to use this at A level. But the idea behind it is essential. That's why I'm doing this video. Now, sometimes you might be given something that looks like this. And it might say, okay, what is the gradient? And it's very, very easy to say the gradient is 4, when in actual fact the gradient is not 4. The gradient is only the coefficient of x if it is y equals, but this is not y equals, this is 2y equals something. So in order to make it y equals, well, we've got to divide everything by 2. Half everything. So 2y divided by 2 is y, 4x divided by 2 is 2x, and 7 divided by 2 is 7 over 2, which I'm just going to leave as a fraction. So now I can say that the gradient is 2. So just a little bit careful there, it must be a y equals. And you can get even more complicated ones, like for example, this tends to be a common way of writing some equations, especially at the sort of A-level end. X plus y equals something tends to be a common way. Now, it is really it can be really difficult to spot what the gradient is at first, but we want it y equals, so we want to get rid of this x. So how do we get rid of a positive x? Well, we've got to take it away from both sides. So we get y equals 8 minus x. Now, some students therefore might say, oh, well, it's not in the form y equals mx plus c, because usually the x goes in front. Now, technically, as long as you can keep the negative onto the x, what this is basically the same as saying is this. X plus negative x. So because you have this addition here, and the reason why you can actually say this is because when you add a negative, that's the same as subtraction. When you've got addition, you can do whatever order you want. So you can actually swap the order of this to make it this. And so the gradient of this line would be negative 1. The y-intercept would be 8. But the gradient would be negative 1. Because it's the value for the x. And lots of students say it's 0, but it's not 0 because there is an x there. So if it's just x, in this case it could be minus 1x. So that's kind of all the very fundamental basic ideas to do with the equation of a line. And remember, it's really helpful to put it in the form y equals mx plus c. So let's have a look at some questions now where we might have to use this. Again, these are from Math Genie, fantastic website. Do check him out. So the line y equals 3x plus 5 crosses the y-axis at p. What is the value of p? Well, p is on the y-axis, as is told. So therefore it must be the y-intercept. Well, we know that an equation in the form y equals mx plus c. M is the gradient, c is the y-intercept, so it must be 5. So what is the value of y at p? It's just 5. Just be really careful about how you read these questions. If it says what is the value of y at p, it's asking for the y coordinate at p, which is just 5. If it said what is the coordinate of p, that's a different question. That is saying what is the full coordinate, in this case 0, 5, because it's on the y-axis, so the x-coordinate's got to be 0. So just be really careful about what kind of question you're actually answering. Write down the equation of another line which is parallel to y equals 3x plus 5. Well, again, that key fact, if a line is parallel, it must have the same gradient. So in this case, you can just write down any line as long as it's y equals 3x. You can add or subtract here. I'm going to say take away 8. Why not? Right then. You can also form an equation of a line. And this is a really nice idea. So form an equation of a line. A line passes through point 0,4, then has a gradient of 2. Write down the equation of the line. Well, first of all, let's write down the general equation of a line, which is y equals mx plus c. And then I just sub in all the bits that I know. So y is the y coordinate, which is 4, is equal to 2, which is the gradient, times the x coordinate of 0 plus c. So what I'm actually doing is I'm working out what the value of c is. I'm working out the y-intercept. So 4 is equal to 0 plus c, c is equal to 4. So therefore the equation must be y equals 2x plus 4. And actually you could have spotted that right at the beginning because the line passes through the point 0,4. 0,4 is on the y-axis, so that actually is the y-intercept. So you didn't really actually have to do all this substitution in to find the y-intercept because it literally told you. All you had to do was sort of just write down the equation of the line. Okay, so have a look at this question here. I'll just give you a few seconds. You could just do it in your head or you can write it down. It doesn't really matter. I'll give you, well, pause the video now and then you can give this question a good go. Right then, so hopefully you've said that the gradient of the line is -3 because it's the value in front of the x, so -3. And write down the coordinates of the point where it crosses the y-axis. Well, the y-intercept is 5, so it's got to be 0, 5. So it's just about making sure we pick out that right value from the equation of the line. Right then, let's have a look at a slightly tricky one. So let's look at this one here. Work out a straight line has equation of 4y take away 5x is equal to 2. Work out the gradient of this line. Well, the end goal is to make it y equals, right? That's the end goal. So what do we need to do to change this to be y equals? Well, we need to add 5x, so we get 4y is equal to 5x plus 2. Now, you could put 2 plus 5x, but I've swapped them over because it's just addition, because you can write it in whatever order you want, and I always like the x to be on the left. And then you just need to divide it all by 4, right, because it's 4y. So 5 over 4x plus 2 over 4, which is the same as a half, but it doesn't really matter. Work out the gradient of this line. Well, the gradient is the value in front of the x, so it's just 5 over 4, which you could write as a decimal, is 1.25, or you could just leave it as a fraction. That is totally fine. Okay, so the diagram shows 4 straight lines labelled P, Q, R, and S. The equations of the straight lines are this, 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 this. Match the straight line P, Q, R, S to its equation. Okay, well, just looking at these graphs here, R and S are parallel to each other, right? So they must have the same gradient. So the gradient of this line is 2x, and the gradient, well, the gradient is 2. The gradient of this line is 2. Now, this has a y-intercept of 3, and this doesn't have a y-intercept, so it goes through 0, 0. So this must be the equation S, and this must be the equation R. Or the line R, should I say. Now, this line here has a negative gradient, so it slopes downwards. See my previous video about gradients. So this one must be P, and just by the process of elimination, that must be D. So a nice little matching thing there. Obviously testing the idea that you know that these two are parallel, so they must have the same gradient. Obviously testing the idea that you know that the y-intercept is 3, so this one goes through the y-axis up here, whereas this one goes through the origin. So a lot of little key skills tested in that question there. Right then, let's have a go at this one, and then we're going to actually plot a linear graph as well. So a straight line passes through the point 0, 5 and 3, 17. Find the equation of the straight line. Well, there are 2 bits of information that you need to know to find the equation of a line. You need its gradient and you need its y-intercept. Now, we can calculate the gradient between 2 points, and this was discussed further in my video yesterday. So if you want to look up that video, then you're more than welcome to, when I talk specifically about how to find the gradient from 2 points. So I'm just going to sort of gloss over it here, but the gradient is equal to the change in y divided by the change in x. So the gradient is equal to 17 take away 5 all over 3 take away 0. So this is equal to 12 over 3, which equals 4. So I know that my final answer must be y equals 4x plus c. I just need to work out what the plus c is. Well, it turns out that we've got the coordinate 0, 5. 0, 5 means 0 cross 5 up. That is the y-axis. So the 5 is the y-intercept. So my final answer is y equals 4x plus 5. How good is that? So all really fun, really. Linear graphs are actually quite sort of alright once you sort of get into them. Now, I would highly recommend, if you haven't done so already, definitely check out these questions by Maths Junior. There's some absolutely fantastic questions on here, testing parallel, perpendicular lines, all sorts of different things here, and I would definitely recommend those. So, now we're going to move on to plotting a linear graph. Now, for plotting linear graphs, well, it's a different skill, but as long as you know how to do substitution, it really isn't much more advanced than that. So, let's say I want to plot this equation here, y equals 4x take away 4. I'm using this table of values here. I just need to substitute these values into this equation. Now, I always like to start on this end because these are positive values, and by working backwards like this, you sort of start on the positives and you might be able to spot a pattern which will help you with the other values lower down. So what I need to do is I need to do 4 times 3, which is 12, because I'm trying to work out the value of 3. So 4 times 3, which is 12, take away 4, which is 8. And then I do 4 times 2, which is 8, take away 4, which is 4. And then 4 times 1, which is 4, take away 4, which is 0. 4 times 0 is 0, take away 4 is minus 4. And then the next one will be minus 8 and minus 12, because it actually goes down by 4 if you work from right to left. And then I just need to plot those coordinates on my graph. So you should get something that looks a little bit like this. And if done correctly, and you know you've done it correctly, because obviously we're looking at straight line graphs, this should be a straight line. So you know you've done it right when it should be a straight line, obviously using a ruler that goes through all those points. There isn't any points that deviate from that line. It should be a nice straight line like that. And then a couple of other checks just to make sure we've really done it right. This is a positive gradient. Remember when we looked at gradient in front of the x value, so this is positive gradient, so the line slopes uphill. So all that very good. Okay, a bit of a tricky one this time, but why not give yourself some time to have a go at this one? You can either have a go in your head or you can write something down. That's totally fine, but whatever you want to do, have a go at this question. So pause the video now to give this question a good go. Okay then, so again I would start on this end just because I think it's easier to sort of deal with the positive value. So 1 take away 2 times 3. 1 take away, well 2 times 3 is 6. 1 take away 6 is negative 5. 1 take away 2 times 1. It's going to be negative 1. 1 take away 2 times 0. Well, that's 1. And 1 take away 2 times negative 2. Well, that would be 1 take away negative 4. And if you subtract a negative, you add. So this is going to be 5. And then we just need to plot the graph. So negative 2, 5. Negative 2, 5. Negative 1, 3. So we're going to get something that looks like this. And then we just need to draw a line that goes through all those points with a ruler. There we go. And the job's a good one. So there we go. There's our line. And obviously there are no points that deviate from this line, so I'm pretty confident that that's going to be right. Now you can get more complicated equations here, and for example, like if I was given, I don't know, something like this. Okay, let's give this a go. If I was given something like this, well, first thing I'd probably draw a table out, and they actually tell you in the question what you should sort of do your table from and to. -1 to 5. So we're going to have the x values here, the y values here, -1, 0, 1, 2, 3, 4, and then 5. Now, it says x plus y is equal to 4. And there are a couple of ways you could do this. You could rearrange this equation into the form y equals mx plus c. And that definitely helps a lot of students. If you do it that way, you get y equals -x plus 4. But you could actually also just look at that equation and do it. It doesn't matter what you sort of do here. But if we use the rearranged form, -5, because it's -x, so if we're starting at +5, -5 plus 4 is -1. -4 plus 4 is 0. -3 plus 4 is 1. And it actually goes up by 1 each time when you move 1 to the left. So it'll be 3, 4, and then 5. So then I just need to plot this graph, and it's going to look something like this. And then we draw a line going through all those points with a ruler, and the job's are good. So even if the equation looks very tricky, the first thing that you should absolutely do in this question is draw a table of values. It makes life so much easier. And actually, you might say, oh, but I don't really need the table of values. I can tell you right now that, especially at A level, a table of values is so important. Because when you look at things like the Newton-Raphson method, you look at cobweb and staircase diagrams, a table of values is so helpful to sort of represent that information, because otherwise it just gets really confusing really quickly. So yeah, highly recommend doing a table of values first for a graph like this. Right then, I think about that just about wraps up all the skills that I'm wanting to sort of cover in this part. In the next lesson, we're going to have a look at non-linear graphs, and this incorporates quite a lot of different graphs. There are several quadratic graphs I want to have a look at. I want to have a look at tangents to those graphs, circles, for example, the equation of a circle. I might do a separate video on trigonometric graphs, because I think that's a different thing entirely, but I might incorporate it. It depends on how long the video is going to be, but the basic focus there is non-linear graphs, so graphs with curves in, looking at tangents, gradients at different points, all that kind of stuff is what we'll be looking at. If you've enjoyed this video, then definitely let me know in the comments, because it's really nice to see positive comments and people enjoying these videos, because that definitely encourages me to make more videos. So all I want to say is thank you so much for watching, and I hope you have a fantastic day.